Okay, so what is going to happen now is we have a series of 5 talks by graduate students. They're approximately 5 minutes long. They are TED-style talks, and they are going to be talking about a variety of research areas, and I am absolutely delighted to share this work with you. They have been working very hard over the past many weeks preparing, and they're about to present their materials, and I think that you're really in for quite a treat. We have a wide variety of topics that are about to be covered. So I will introduce each speaker, and they will come to the stage and go through their presentation, and then I will come back up after each one, just so that we can keep the flow. So, okay, our very first speaker. Great, we're ready. Jorge's ready. Our very first speaker is Jorge Reyes, who is a PhD candidate in mathematical sciences, and he'll be talking about the foundations of science and society. Welcome, Jorge.
Thank you to Dean Crittenden for the introduction. Yeah, my name is Jorge Reyes, and I'm a PhD student in computational mathematics. All right. So mathematics, right, is the M in STEM and the queen of the sciences. And just like in real life, we know that the queen really rules, okay? However, math is kind of mysterious, right? No one really knows what a mathematician does. So I'm going to hopefully show you one example or one interpretation of what mathematicians do. And I'm going to reference it in this analogy of making tools. So there you see a paintbrush. And the paintbrush is a tool used by an artist to create paintings or masterpieces, right? And now we see a needle and thread, right? Those are tools of a tailor to make alterations to dresses and make fashion. And we see many other tools made by other professionals, right? And in our modern society, governments, labs, businesses require tools a little more computational and mathematical at their hearts. And so I'm going to drive and show you a little bit of my research and the tools that I make as a computational mathematician. All right, and so here we see a slide. And essentially what I do is I solve problems, okay? And so if someone told you to solve the thing on the top left, I think you'd classify that as a problem, right? That's a problem. And so I use the finite element method to transform that equation into essentially an algorithm there at the bottom, something that a computer can understand and something that someone can run, okay? And so if I was to solve this equation on this box here, if we can imagine water moving from left to right around the 3 circles, I would mesh the domain like this and run my program and get this solution, right? And so this is how the water would move around the 3 circles. All right, and now that you've seen this, let's kind of take it into the real world, okay? And so here I have the Pittsburgh River system. Actually, at the top, you'll see the Steeler Stadium, okay? But let's imagine there was a spill of some kind, okay? And so I would take this sky image of the river system, simplify it a little, and then I would run my program, my code, to get these 2 answers, all right? So on the left, you see how the water would flow in the river, and on the right, you see how the contamination would follow that flow. And so environmental or civil engineer could use this to help inform them when to test, where to remediate, okay? And so that's what the engineer would do, right? I, as the mathematician, though, just made this tool, all right? Just like mathematicians did not make the Apollo 11 rocket, right? That was engineers and rocket scientists. However, Katherine Johnson, right, fought racism and segregation inside of NASA to calculate the trajectories so that we could actually get to the moon and get back safely. All right, and she was different. She solved problems differently, which her story can be seen in maybe the movie you've watched, Hidden Figures. Okay, great movie, would recommend. All right, Another famous mathematician, Saranavase Ramanujan, was the first Indian elected to the Royal Society. And he is famous for being revolutionary and different, all right? He completely changed how we thought about math. And I use these two mathematicians to highlight a problem, all right? Without them, there would be problems left unsolved, all right? Because when everyone is the same, everyone might think the same, and everyone will get stuck on the same problems, okay? And so mathematics is really at the foundation of all sciences, at the heart of everything. And in our society, we're becoming more and more reliant on computers, right? Like ChatGPT, AI, machine learning, all right? However, actuaries have been using math for years to calculate how much you pay for health insurance, how much you pay for car insurance. And engineers and mathematics go hand in hand, right? You can't really engineer without mathematics as your tool. And so to diversify math is to diversify the foundation of our society and not just science. All right. Thank you.
Thank you, Jorge. Well done.